Evolution of computing devices. Hi, I'm Jaydeep Sai and I am from CSEB section. Let's discuss about evolution of computing devices. What is computing? Computing is any goal-oriented activity requiring benefiting from or creating computing machinery. It includes the study and experimentation of algorithmic processes and the development of both hardware and software. It has scientific, engineering, mathematical, technological, and social aspects. Major computing disciplines include computer engineering, computer science, cybersecurity, data science, information systems, information technology, and software engineering. So, we have the question about what is computing. So, computing is any goal oriented activity which is requiring benefiting or creating computing machinery. So creating machinery or requiring any computing machinery, it is called as computing. It also includes the study and experimentation of algorithmic process and development of both hardware and software. It has scientific, engineering, mathematical, technological, and social aspects. So the computing has many aspects such as scientific, engineering, mathematical, technological, and also social aspects. So the major computing disciplines include computer engineering, computer science, computer cybersecurity, data science, information systems, information technology, and software engineering. Evolution of computer machines. During the period of 3000 BC to 1450 AD, human beings started communicating and sharing information with the aid of simple drawings and later through writings. The introduction of numbers led to the invention of abacus, the first computing machine. In the following section, we will examine some important milestones in the evolution of computing machines. First one is abacus, and second one is Napier bones. Third one is Pascaline. Fourth one is Leibniz calculator. Fifth one is Jacquard loom. Sixth is difference engine. Seventh one is analytical engine and Hollerith machine, and the last one is Mark 1. So at the period of 3000 BC to 1400 AD, human beings started communicating and sharing information with simple drawings and later through writings. So at the time of 3000 BC, before 3000 BC, the humans have started communicating with each other by using the simple drawings and the gestures and symbols. They used to draw the arts. We have many caves. We can see the drawings of the humans which are used to communicate with one another. And later, due to the evolutions, the humans slowly started writing. So during the writing, the introduction of numbers led to the invention of abacus. So while writing, the humans started inventing numbers. And while inventing numbers, it led to the invention of the abacus. Abacus is the first computing machine. So we know that abacus is a computing machine. It's a mechanical tool which is used for the calculations, and it also performs the calculations such as arithmetic and addition, multiplication. Many operations can be performed by using abacus. So it was one of the oldest computing machine. So here is the diagram for the functions of the family. The first one is abacus and Napier bones, Pascaline, Leibniz calculator, Jacquard loom, difference engine, analytical engine, Hollerith machine, Mark 1. So these are the different computing machines which are used, and these are the evolutions from the starting. The first starting of these computing machines is first one is abacus. Through it was used to calculate the calculations, and it is also used as a calculator in olden days. So the abacus has many, it was developed and it has many technical advancements have been done to abacus, and many computing machines were evolved from the abacus. So these are the some of the calculators and computing machines which are evolved from the base computing machine, which is abacus. So these are the functions of the family. First one is abacus. The Stone Age man used pebbles for counting cattle. Later on, when man become more civilized, abacus come in use. Abacus seems to be the earliest calculating machine, which was developed by Chinese 3000 years ago. It consists of a rectangular wooden frame with horizontal rods and which carry round blades. So many would have seen the abacus. It was first invented in China 3000 years ago. So at the Stone Age, the humans used to count the cattle and the sheep which they grow by using their pebbles and stones. So they used to know how many sheep and the cattle were there by counting the pebbles. Later on, the man became more civilized. So later on, the man became more civilized and intelligent. So he invented the abacus. Abacus seems to be earliest calculating machine. So abacus is one of the earliest calculating machine which is developed in China 3000 years ago. It consists of a wooden rectangular frame which contains horizontal rods which carry colorful beads and which are round in shape. So this is the picture of abacus. We can see here this is a picture of abacus. Here the vertical rods are there in a rectangular arrangement is there. Here we can also see the beads which are round in shape, and here upper deck is there. And this abacus is divided mainly to two halves. One is upper deck and next one is lower deck. And here we can see the beads in both upper deck and lower deck. And the upper deck and lower deck is separated by a beam, and we can see the rods and frame. The frame is in rectangular shape. So this is abacus. Counting is done by shifting the beads from one side to another. Abacus is still being used in China, Japan, and part of Soviet Russia for primary education. So this abacus is still in use by many countries, such as in it is still in use in China and Japan and many Soviet unions in Russia. In their primary education, the students are taught the use of abacus from their early age in the primary educations. So the abacus is also called a counting frame. So this abacus, due to its in rectangular shape, it's a rectangular frame, so it is also called as counting frame, a calculating tool for performing arithmetic operations. So we know that this abacus is used for arithmetic operations. The Chinese improved abacus as a frame holding vertical wires with 7 beads on each wire. A horizontal divider separates the top 2 beads from bottom 5. So this abacus was developed by Chinese. How abacus works? The abacus works on the basis of a place value system. Reading it is almost like reading a written numeral. Each of the 5 beads below the bar has a value of 1. Each of the 2 beads above the bar has a value of 5. The beads which are pushed against the bar represents the number. Abacus is used even today by children to learn counting. A skilled abacus operation can be as fast as handheld calculator. Shown the addition of two single-digit numbers. Shows how two numbers are added. So this counting of the numbers is done by using abacus, which is based on the number of beads. So in the first upper deck, the beads has a value. A single bead has a value of 5, and in the lower deck, each bead has the value which is equal to 1. So this calculation is done by pushing the beads against the bar. So while pushing the beads against the bar, which it will represent a number. So if we use the abacus and we are skilled in by while using the abacus, then we can perform simple arithmetic operations as fast as a calculator. Napier bones. This is the next evolution of the computing machines. The next pioneer contribution was made in 1614 AD by a Scottish mathematician called John Napier. He evolved the system of the logarithm by 1617. He had improved on his device which could perform multiplication and division as well. This was later known as Napier's bones. So this is the computing machine which was invented by a Scottish mathematician. He was named John Napier. It was invented in the year 1614 AD. So the Scottish mathematician named John Napier invented these Napier bones, which is a good evolution from the abacus. It's different in the calculation methods. It is used to perform the multiplications and divisions as well. It was called as Napier bones. The strips of Napier's bones are the times tables. Each square gives 2 into numbers, 3 into columns, and so on. But the tens and units are written above and below a slanting line respectively. Napier's bones is good for multiplying a long number by a single digit number. Let us multiply 425928 by 7. First, they take the strips for 4, 2, 5, 9, 2, and 8 and fit them into the frame. Look at the squares next to the 7 on the side. It is colored green in figure. Now, read the digits. Any number within slanting lines must be added. Next computing machine is Pascaline. The first mechanical calculating machine was made in 1642 by a great French mathematician and philosopher, Blaise Pascal. His machine was a simple calculating used for additions and subtractions purposes. So Pascaline is another computing machine which was developed by French mathematician, and he was also a philosopher who was named Blaise Pascal. His machine was mainly introduced to perform the additions and subtractions. So this computing machine calculates the addition of the numbers, and also it is used for the subtraction of the numbers. Pascal invented this arithmetic calculator to assist his father in his work as a tax collection supervisor. This machine was operated by dialing a series of wheels, gears, and cylinders. He called it Pascaline. Consider adding the numbers 20 and 81 using Pascaline. Initially, the Pascaline will be set to 0 for all the 6 digits. To dial 20, you just have to put your finger into the space between the spokes next to digit 2 of a second wheel and rotate the wheel in clockwise direction until your finger strikes against the fixed stop on the bottom of the wheel. So the Pascaline invented this mathematical calculating device, which is an arithmetic calculator, to help his father because his father was doing many calculation works as he was a tax collection supervisor. So his father was a tax collection supervisor. He was performing many arithmetic operations without using any tools. So that's why the Pascal invented this calculator to help his father. Next calculator is Leibniz calculator. This is another computing device. In 1673, the German mathematician philosopher Gottfried Wilhelm von Leibniz designed a calculating machine called the step reckoner. The step reckoner explained on Pascal's idea and extended the capabilities of perform multiplication and division as well. Leibniz successfully introduced this calculator onto the market. So as we know that Pascal's machine was only used to calculate the arithmetic and subtraction operations of the numbers. So Leibniz invented a calculator which has extended the capabilities of this Pascaline calculator, and it was also performing multiplication and division operations as well. So because of that, it went very famous and it was introduced onto the market. So it had high demand at that time. His unique drum-shaped gears formed the basic of many successful calculator designs in later years. The step reckoner is a calculating machine that was based on a same principle as that of Pascal's. The only added feature was a system of shift mechanism operating through a series of decile. Jacquard loom. The Jacquard loom is a mechanical loom invented by Joseph Mary Jacquard in year 1801 that simplifies the process of manufacturing textiles with complex patterns. The loom is controlled by punched cards with punched holes, each row of the which corresponds to one row of the design. So this was also one of the computing machine, which is a calculator, and it was like a mechanical loom. It was inspired by the mechanical textile with complex patterns. The loom is controlled by punched cards with punched holes, each row of which corresponds to one row of the design. Multiple rows of the holes are punched on each card, and the many cards that compose the design of the textile are joined together in order. The Jacquard loom not only reduced the amount of human labor, but also allowed to store patterns on cards to be utilized again to create the same product. These punched cards were innovative because the cards had the capability to store information on them. This ability to store information triggered the computing revolution. The punched card concept was adopted by Charles Babbage to control his analytical engine and later by Hermann Hollerith. So this machine was invented by using the concepts of the textile working. So where the numbers are represented by punching the holes on the cloth. So this by doing this process, the numbers are represented by holes. So they remains on the cloth. As a result, it is stored without any storage. So this concept was evolution. It became an evolution, and this concept of storing the data is extended by Charles Babbage to control his analytical engine and later by Hermann Hollerith. Difference engine. The first step towards the creation of computers was made by a mathematics professor, Charles Babbage. He dreamed of removing the human element from the calculations. So, different engine is a calculating computing device which was invented by Charles Babbage. So, to reduce the human element from the calculation, to remove the human effort while doing the calculations, Charles Babbage want to remove the human effort. So, this led to the invention of the computer. He realized that all mathematical calculations can be broken up into simple operations which are constantly repeated, and these operations could be carried out by any automatic machine. Charles Babbage started working on difference engine that could perform arithmetic calculations and print results automatically. In 1822, Babbage invented the difference engine to compile mathematical tables. On completing it, he conceived the idea of a better machine that could perform not just one mathematical task but any kind of calculations. Analytical engine. In 1833, Charles Babbage started designing the analytical engine, the real predecessor of the modern day computer. Analytical engine marks the development from arithmetic calculation to general purpose computation. The analytical engine has many features found on the modern digital computer. The engine has a stored memory, while numbers are and intermediate results could be stored, and separate mill processor where arithmetic processing could be performed. Its input-output devices were in the form of punched cards containing instructions. The difference engine and the analytical engine earned Charles Babbage the title father of computers. So we know that the Charles Babbage is the father of computer. So he was given name because of the invention of the difference engine and analytical engine, which earned Charles Babbage the name father of computer. Hollerith machine. In 1887, an American named Herman Hollerith fabricated the first electromechanical punched card tabulator that used punched cards for input, output, and instructions. The card had holes on them in a particular pattern, having special meaning from each kind of data. In 1880s, the US Census Bureau had huge amounts of data to tabulate. It would take at least 10 years to analyze population statistics manually. Herman Hellerith's greatest breakthrough was his use of electricity to read, count, and sort punched cards whose holes represent data. His machines were able to accomplish the task in 1 year. In 1896, Hellerith started the Tabulating Machine Corporation, which, after a series of mergers, became International Business Machines (IBM) Corporation in 1924. So we know that IBM is a company which was founded by Hellerith for the Tabulation Machine Corporation. Mark 1. It is the last evolution of the computing machines. In the 1944, Howard Aiken, in collaboration with engineers at IBM, constructed a large automatic electromechanical computer. Aiken's machine, called the Harvard Mark I, based on Babbage's analytical engine, handled 23 decimal place numbers and could perform all four arithmetic operations. It was pre-programmed to handle logarithmic and trigonometric functions. Using Mark I, two numbers could be added in 3 to 6 seconds. For input and output, it used paper tape readers and card readers, card punch, and typewriters. So at last, Mark I was invented, which is a mechanical computer which was pre-programmed to handle logarithms and trigonometric functions. So before we used to calculate only arithmetic operations such as multiplication and addition, subtraction, division. So later the Mark I was invented, which made the calculation very efficient by introducing the logarithms and trigonometric functions concept. Using Mark I, two numbers could be added in 3 to 6 seconds. So by using Mark I, we can add the numbers in at least 3 to 6 seconds. For input and output, it used paper tapes reader. So it also had input and output. By using the paper tape readers, card punch, and typewriters. I thank the faculty and college for providing me this opportunity to speak on the topic. Thank you.